So far we have done this D block properties as an art integration form, as a Diwali celebration, as a Diwali decorative items. Let's move and see the variable oxidation state of D block element. All of you come and let's check. Okay, now. So this is the oxidation state of transition elements, and we are discussing only one series, that is 3D series. Okay, let's see how the oxidation states are varying of all elements of the particular series, that is 3D series. All of you know scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is 3D series element. And what is the configuration of scandium? Let's see what is written. Argon 18, 3D1, 4s2. So what is the outermost configuration? That is 3D1 and 4s2. So what is the total valence electron? 3. So how many electron can we lose from here? 3. So we see how many variable oxidation state possible of each element. So now you can see it's very nicely presented in the form of this wall hanging at the door, and you remember this one also, and this one is, now you see what is oxidation state of scandium?
+3.
+3, +2,
+3,
titanium +2, +3, +4. So like this you can see.
Ma'am, why is +4 encircled in titanium?
Okay, very good question. Okay, this +4 has been circled. So you can see in all cases the oxidation state has been circled. Here 3, here 4, here 5, here 6, even here 3 also, and the other 7, here 2 also. In case of iron, 2 and 3. In case of cobalt, 3. In case of nickel, +2, copper +2, and zinc only 1 oxidation state, right? So why these has been circled? And very good question, because of these has been circled as a stable oxidation state. And you know the oxidation state stability depends on what?
Ma'am, the valence electrons.
Yeah, configuration. We can say configuration. So the last one, with anyone with the circle, that is a stable configuration, and especially the last one, that is +4, because after loss of 4 electrons, what configuration is left? Argon. That is a noble gas configuration, right? So this is the reason. So these circle are stable oxidation state, and the oxidation state are stable due to stable configuration, either in terms of noble gas configuration or half-filled. As you can see, these are the stable configuration, +4, +5, +6, +7 due to noble gas configuration. But in between you can see chromium. What is the stable state?
Ma'am, +3.
+3 also stable state. Why +3 is stable state? Already I told in the discuss in the class. Okay, again repeating. What is the outermost configuration?
3d5, 4s1.
Yeah. So how many electron can we lose over here?
6.
Okay, +3 means there is a loss of 3 electrons. First from S and then from D. So S 1 electron has been lost, और D से 2 electron निकल गया. So what the configuration is left? 3D3, and 3D3 is a half-filled.
Half-filled T2G, ma'am.
In terms of T2G3, very good. Because you think that D5 is the half-filled, but D3 half-filled is also stable configuration and more stable than D5, because in terms of T2G3, which we have already discussed in the coordination chapter. Okay, so like this, here also you can see the Mn has +2 also stable, beside +7. Why +2 stable? Because of loss of 2 electrons. What is left? D5.
D5.
That is a half-filled. Okay. Similarly, iron has +3 because of half-filled configuration. So you can see the scandium has only 1 oxidation state, and after that there is a 1,1 oxidation state increases. And what is the common oxidation state in all cases?
Ma'am, +2.
+2. So +2 is the common oxidation state of 3D series. But +2 means after the loss of S2 electron. But after the loss of S electron, then the electron loses from D orbital also, 1 each. So +2, then what? +3, then +4. +4 means noble gas configuration. So you can say 4, now 2, 3, 4, 5. Then what happens? 6, Then what happens? 7.
7.
So initially you can see the oxidation state increases till manganese, and manganese is the maximum variable oxidation state.
Yes, ma'am.
So why initially first increases? Because of increase of number of unpaired electron in d orbitals. What is the configuration of scandium? D1, 1 unpaired. What is this? D2,
D2.
2 unpaired. So as the number of unpaired electron increases, the oxidation number also increases because unpaired electron participate in bonding. So Mn has the maximum number of unpaired electron. So this is the reason Mn has the maximum number of variable oxidation state. But then after start decreases. After Mn, so you can see this is just like a pyramid also you can say, or it is just like a wall hanging also. So first increases till manganese, and then it start decreases. You can see why start decreases, because after Mn means from iron the electrons start pairing, because iron configuration is what? 3d6. 3d6 means now
Pairing
5 unpaired,
starts.
and in case of Mn there is a 5 unpaired, but in case of iron 4 unpaired and 1 paired. So from D6 the pairing of electrons start, and the paired electron not participate in the bonding. So this is the reason the oxidation of the start decreases. And why zinc is only 1 plus 2? Because there is a loss of only S2 electron.
4s.
Because D is now fully filled. Okay. Now there is a 2 questions arises. Why scandium does not show plus 2 oxidation state, right?
Yes, ma'am.
I told the common oxidation state is plus 2 because of loss of 4s2 electron, right? So scandium has also tendency to show the plus 2 state, but plus 2 is not what? Stable. Why plus 2 does not show? I already discussed in the previous class even also. Anybody can reply? Shall I repeat once? Okay. So why plus 2 is not stable? Because after loss of s2 electron, how many electron left in d orbital? 1. d1. And 1 electron easily can be lost by less amount of energy to attain the noble gas configuration, right? So this is the reason that plus 2 easily oxidizes into plus 3 and attain the argon as a noble gas configuration, or we can say d1 is not very stable and can and has tendency to lose that electron, right? Okay, now 2-3 more questions. If I ask, name the transition element which does not show variable oxidation state.
Ma'am, zinc and scandium.
No, not zinc, only scandium. I ask question, name transition element.
Yes,
And zinc
ma'am.
is not a transition element because already we have discussed zinc is not a transition element because its d orbital is completely filled, right? So scandium, name one transition element. That answer will be scandium because scandium is transition element. Okay, but if I ask, name one d block element which does not show variable oxidation state, in that case what you can say, either scandium or zinc. D block, because both are D block element. In case of D block, you can write any one of the answer, scandium or zinc. But when the question will ask, name the transition element, then answer is only scandium. And why scandium does not show variable oxidation state, only one oxidation state, already I have discussed. Second question asks, why manganese is more number of variable oxidation state, just I have discussed, because more number of
Maximum unpaired electron.
electronic. And one more question is very very important. Copper 1 plus, copper 2 plus. Copper 1 plus. What is the configuration of copper? 3d10, 4s1. Plus 1 means loss of 1 electron. S1 से एक electron निकल गया. So what is left? D10.
3d10.
And D10 is a highly stable configuration. So plus 1 should be very very stable oxidation state. But plus 2 is also more stable in aqueous state. So in copper, plus 1 where the D10 configuration is still 2 plus is more stable in aqueous state because of high hydration enthalpy. Because, and why high hydration enthalpy? Because copper 2 plus has a smaller size. And due to high hydration enthalpy, copper 2 plus is more stable T plus table. Already I told was T2, T3 half-life configuration. So this concept, the variable oxidation state of transition metals, it can be easily understood by this Diwali decorative item. And this decorative item you have prepared, all of you have prepared, all of you made it. So I hope it is clear to all of you. So let's enjoy Diwali celebration and let's happy Diwali to all of you. Thank you so much.